Hello, this is module 9, first hop redundant protocol concepts. This is semester 2. So in this module, we're going to cover these topics: first hop redundant protocol purpose, and then operation of first hop redundant protocol, then standby routing protocol to look at how it operates. So those are the two areas that we're going to cover in this module. So we need to look at the background first, that every edge device is typically configured with a single default IPv for address. If the default gateway router interface fails, then the LAN host loses outside LAN connectivity. So this occurs even if a redundant router or layer 3 switch that could serve as default gateway do exist. So first hop redundancy protocol, a mechanism that that provides alternate default gateways in switched networks where two or more routers are connected to the same VLAN. So when you look at what we have here, that okay. So when you look at the topology here, it is supposed to be assigned with IP address, then the subnet mask, and then the default. This gateway, let's assume that the gateway is this interface here. This interface. That if this interface, this link is down, however much we have the redundant link here that could actually serve, we have the redundant link that could serve as the default gateway, but it is not stated here, so it's not going to help this redundant link. So first hop redundancy protocol are the mechanism that provide alternate default gateways in switched network. That if you have a design like this one here, it gives us a mechanism. We can actually use first hop redundancy protocol mechanism to serve as the gateway in case, let's say, one of the link here goes down. It's what you're going to cover. One way to prevent a single point of failure is that if this one here is down, then this network here goes down. So to eliminate that, one way to prevent such at the redundant gateway is to implement virtual router. So we're going to come up with a virtual router that if it use the gateway, it can't be the IP address of this interface here, neither the IP address of this interface, but we have to use the virtual that will appear on this and then even on this interface. That even if this one here goes down, but our virtual IP address still exists this side, so it will be used that side. So to implement this type of router redundancy, multiple routers are configured to work together to prevent the inclusion of a single router to the host of LAN. So by sharing IP address and MAC address, that is the IP address that you're going to assign here, the same here and the same again on this. By sharing the IP address and MAC address, two or more routers can act as single virtual router. Router. So the IP address of the virtual is configured as the default gateway. When a frame are sent from host device to the default, the host uses FHRP to resolve the MAC address that is associated with IPv for address of the default gateway. So the FHRP resolution returns the MAC address of the virtual. Then frames that are sent to MAC address of the virtual router can then be physically processed by the current active router. So protocol used to identify two or more routers as the devices that are responsible for processing frame data sent to the MAC address or IP address of a single virtual router. Host device sends traffic to the address of the virtual router, then the physical router that forwards this traffic is transparent to the host. So in this process, let's assume that we have the redundant this and this connects to the switch. So we're going to introduce the virtual router, which you will not be able to see, and then the IP address we're going to look for. This it has to be assigned. Let's assume .1, and then this one here it can be signed maybe .2. Okay, and then this PC of ours here, now it has to use one IP address. So this PC, it cannot use one, neither it can't use two. Because if you do that, then it means that there is a limitation that if this link goes down and the subnet mask, so the default gateway is 2, then it won't access. So we're going to introduce the virtual IP. For example, we can call this 3. We assign it on this, and then again 3 this side. But it will be virtual, and then there must be active and then standby. That every time the packets are sent, now the active, it's the one to process them with this interface. But in case, let's say this one here is down, and yet our 3 is still exists this side, then the standby, it's going to come into play and act as a redundant to forward the traffic. So a redundant protocol provides the mechanism for determining which router should take the active role in forwarding traffic. It also determines when the forwarding role. Must be taken over by standby router. So the transition from one forwarding router to another is transparent to the end device. It is transparent because it's only one IP address that is going to be used. So the ability of network to dynamically recover from the failure a device acting as the default gateway is known as first hop redundant. So this is what I explained, the other side, what really happens, that we have two physical routers, this and then this, for redundancy purpose. Now, these are physical interface, this, and then there is what we call the virtual address. So with the virtual address, the virtual router, it's the one that is assigned this IP address. But this IP address, this router, it's not going to be physically seen. So this, instead we introduce this address. And this address, it has to exist onto this together with the IP address assigned on the physical interface. These are physical interfaces. But on those physical interfaces, we're going to attach the virtual IP address, this. And but to manage this, there must be an active router and then the standby. So the standby, it will come into play when the active fails or stops working, or when the standby fails to see the active on the network. So the standby router stops, we can start from this. When the active router fails, then the redundant protocol transition the standby router to new active router role as shown in the figure. So these steps, these are the steps that take place when the active router fails. The standby router stops when it stops seeing the error messages from the forwarding router, that is the active router. The standby router assumes the role of forwarding router. If it stops seeing the messages, then it will assume. Because the new forwarding router assumes both IP and MAC address of the virtual router, then the host device sees no disruption in the service. because this is just virtual, whatever information, because here there is virtual IP address and virtual MAC address. They do exist here and then even on this interface. So once the active fails, then the standby comes into play, but the IP addresses remains the same. So there won't be any disruption there. So the first hop redundancy protocol options, they're there. We have hot standby router protocol. Here it is a Cisco proprietary protocol. It's a Cisco proprietary protocol, which is this Cisco proprietary protocol. It runs on Cisco devices. Then we have for IPv6, still it's a Cisco proprietary, but for IPv6. We have virtual router redundancy protocol, version 2. This is non-proprietary, meaning that it can run even on non-Cisco devices. We have virtual router redundancy protocol, version 3. Now for version 3, it supports both IPv4 and then IPv6. Then we have gateway redundancy, gateway load balancing protocol. This is a Cisco proprietary protocol. Then we have gateway load balancing protocol for IPv6, still it is Cisco proprietary. Then we have ICMP router discovery protocol. It's a legacy first hop redundancy protocol solution. So this is the absolute mechanism. And then we have this, mainly these two here. They cut across their neutral, their vendor neutral, this, and then the rest, this one here, and then hot standby. These are Cisco proprietary protocol. Hot standby router protocol overview. Cisco provides HSRP, the HSRP for version 4. This flat. This is flat. It's for IPv4. Then this is for IPv6, as a way to avoid losing outside network access if the default router fails. HSRP is a Cisco preparation, as we said. HSRP ensures high network availability to make sure that the network is always available. That even if, let's say, one of the link goes down, then the redundancy will come into play. So HSRP is used in a group of routers for selecting an active device and then standby. So it has to work in a scenario where we have more than one, the redundant device. Redundant, so that one is the active and then we have the backup. So the standby device is the device that takes over when the active device fails, when the preset conditions are met. So the function of HSRP standby router is to monitor the operational status of the HSRP group and to quickly assume packet forwarding responsibility if the active router fails. So here we have the topology, and it's what ideally it's what we're supposed to find. It's not a complicated topology. All we need is just to set this up. Most of the time I just abbreviate this with a router, and then you do the assignment of this, and then you assignment of this, and then you you decide the active and then the default. Just to catch the story short, it's like the role of active router and standby router is done during HSRP election process. So by default, router with the numerical highest IP address, IPv4 address is elected as the active router. So among these, when you look at this, it is 172.16.10.2. Then this side it's 10.3. So ideally this is the active router by default. But that is when all other factors are constant. That is by default. Then this one here, it becomes an active router. Um, However, it is always better to control how your network will operate under normal condition rather than uh, leaving it to chance. So HSRP priority can be used to determine the active router, the priority. Now the priority is here. The higher the priority, then the preferred router is going to be. So this, by default, it's 100, the priority. But this one here, it was raised up to 150. That's the reason why it is active. So the router with the highest HSRP, this will become active. I will say by default, HSRP priority is 100. If priorities are equal, then the router with highest with the numerical highest IPv4 address is elected as the active router, what I explained in the first place. So to change the router to be the active router, use standby priority under interface command. Then the range of HSRP priority, it ranges from 0 up to 255. The higher the higher the priority, then the higher chances of that router to become a priority. So that is it for. So after we doing that, by default, after the router becomes the active router, it will remain active router even if the other router comes online. That, for example, let's say they were on that by default, and then we raised this to 150. Then, of course, this router too would have remained as active. Would have remained. So to force, now we've raised it to 150, to force this to become an active, then to force the new HSRP election process, then process to take place, when the higher priority router comes online, preemption must be enabled using standby, then preempt under interface. Preemption is the ability of HSRP router to trigger the re-election process. So the re-election process is going to start up afresh. With preemption, with an preemption enabled, a router that comes online with the highest HSRP priority will assume the role of active. So once this command is added onto the interface commands, then every time you add or you change in the priority number, then automatically, if the condition is met, then the process is also re-triggered. It is re-triggered. Preemption only allows the router to become the active router if it has the highest priority. So a router enabled for preemption with equal priority but higher IP address will not preempt an active. So refer to the topology of the figure. So the topology is this. Note, with preemption disabled, the router that boots up first will become. So if the preemption is disabled, whichever router that comes up first, it's the one to assume the role of active. So there are states, the HSRP stands for Hot Standby Router, router protocol. The states, we have initial, the initialization, we have the initialization, we have learn, listen, speak, and then standby. So the descriptions are here. You can even go through your slides so that you get to go through this description, that the state is entered through configuration change, or when an interface first becomes available. Then the router with LAN, the router has not determined the virtual IP address and has not yet seen hello messages from the active router. Then listen, the router knows the IP address, virtual IP address, but the router is neither the active router nor standby router. Then speak. We have router sends periodic hello messages, actively participates in the election of the active and or standby router. Then lastly, standby, the router is a candidate to become the next active. It is on standby to become an active router. So the active and standby router send hello packets to HSR group multicast address every 3 seconds by default. So every 3 seconds by default, the message has to be sent. So the standby router will become active if it does not receive hello messages from the active router after 10. So it has to wait actually 3 times. Count 3 minutes, 3 seconds, 3 seconds, 3 seconds, then on the 10th, then automatically the standby router, it will assume. So you can actually lower this timer setting to speed up the failover or preemption. So however, to avoid the increased CPU usage and unnecessary standby state, do not set hello timer below 1 second. So the least it can be 1 second, or hold timer. For the hold timer, this is the time that it has to wait for, the standby has to wait for hello message. So after 4, if the hello message is set to 1, then the hold time, it has to be 3 times. Has to be 3 times. Yeah, so yeah, that marks our the end of the session.